Okay, let's start. My name is Johan Thornborg, and I'm the founder of Redfield company. So Redfield is specialized in data warehousing, big data technologies, and advanced analytics. So we are also trusted partners to KNIME, and for this reason we have invited Kilian Thiel from KNIME. So Kilian is a really skilled data scientist and also the manager of the Berlin headquarters. So Kilian will be talking about KNIME's overall features together with some really interesting use cases. Also I have Artem Ryasik with me. So Artem is a Redfield employee. And Artem, he will cover the basics of anonymization. And he will also show how to do this automatically in KNIME. And also we have some exciting news, something that we have been working on for last weeks. It's the integration between KNIME and ARCS. So ARCS is a very powerful anonymization library. So by combining those tools together, we get a very powerful anonymization system that you can do the anonymization in real time, completely automated. So the agenda for tonight, I will just present the Redfield team and also share some thoughts about AI and the direction of AI. Then I will hand over to Kilian. He will give a KNIME introduction, cover the basics of KNIME. And then we have two really interesting use cases: inventory optimization, customer intelligence, and then data anonymization that Artem will cover. So this will take about 1 hour and 50 minutes, and I would like to encourage you to stay here. You can grab some more food and wine or beer, and we can talk more about your current products and future products. I think that will be interesting. And don't hesitate to approach me, Kilian, or Artem if you have any questions. We can help you, for sure. So this is our advanced analytics team. It's me, myself, Artem, Fredrik Norlin, and Jan Lindqvist. We have Jan here in the audience. So he is a GDPR expert, privacy advisor. Do you like to say a few words? Okay. Yeah, great. Thanks. We have also a data warehouse ETL team, a very hard-working team. Kavita, Sanders, Klaus, and Princey. So they are really experts in integration, data warehouse, and ETL. So what is important for us is the democratization of AI to be able to share this technology with more people. So we think this should be for every person and every organization. So it's not only the technology itself, it's also the data, because if you are developing some clever algorithms, the chances are high that you will use some personal information. And if you're going to share that with a lot of people, you have to make sure it's safe. And we have a method of using the machine to anonymize the data, so you can share it in a safe way. So we covered already that this technology is kind of complicated. It's difficult to maintain, to tune, and the expertise is quite limited. So from history, we can learn that all technology must undergo some kind of standardization to be accessible and successful in the long run. So one way of doing this is to create like an abstraction layer on top of this technology that will hide unnecessary complexity and make it more available, accessible to more, to everyone, in fact. So we think that KNIME is a good product for this because it's so easy to use. You have integrations to most of the machine learning libraries, deep learning libraries. And what I can tell is that when I started my career 20 years ago working with data warehousing, there was still some people saying that it's better to use coding only. But I mean, now this is not an acceptable solution. We're using ETL tools with graphical interfaces. So I'm sure that AI will move into in the same direction. So if we see KNIME as an abstraction layer, some words of wisdom. The purpose of abstraction is not to be vague, but to create a new semantic level in which one can be absolutely precise. So now let's move forward with Kilian's speech, KNIME Introduction, Inventory Optimization, Customer Intelligence.
Good. Yeah, thank you for the invitation. Thank you also for hosting this event. I'm happy to be here and to introduce KNIME to you. First of all, I'll start with the question, what is KNIME, and give you a brief introduction into KNIME. A little bit or mostly about the KNIME Analytics Platform and also a little bit about the KNIME server. And then I'll have two demos, a demo about inventory optimization and a demo about customer intelligence. I'll show these demos. I have a couple of backup slides in case the demo crashes or something happens, but hopefully everything goes well and I can show you the demo live. So first of all, what is KNIME? Quick question here. So who of you have heard KNIME and is already using KNIME? Okay, so a couple. That's nice. That's good to see. So for the others, I'll have this quick introduction. The KNIME Analytics Platform is an open source and free platform for doing data analytics. It's all visual. For example, here you can see a screenshot, and it gives you, it gives you the possibility to visually assemble a workflow and perform specific operations on your data by defining that workflow. Here you see a little example. We have various operators, and these operators are called, this doesn't work. These operators are called nodes. You can see, for example, here a partitioning node, and this node performs a specific operation on the data. In this case, it partitions the data. It takes the input data and splits it up into two data sets and outputs the data on the output ports. So you can see that all the nodes, they have inputs and outputs, most of them at least. They have a name. They have also a traffic light that you can see here that indicates the status and so on. And you can take these nodes and you can connect these nodes visually in the KNIME Analytics Platform to visually assemble your workflow. For example, here there is the file reader node. This simply takes a file, reads the data from that file, for example, a CSV file. Then it hands over the data to the next node, the color manager, which applies a color information. It hands over the data to the next node, which applies partitioning, and then the random forest learner, for example, trains or builds a predictive model on the input data and so on. And so step by step, these operations are chained together, and they are performed on the data step by step. With this, you can build very complex workflows and you can perform very complex tasks in an easy way because it's all visual and you can easily, for example, create your random forest without the need to code complicated Python or R scripts. You can do this, but you don't need to. Switched it off. So far in KNIME, there are over 2,000 native embedded nodes. KNIME is based on Java, so these native embedded nodes are implemented in Java. And these nodes are roughly categorized in these categories that you can see here. So we have nodes for data access. These nodes, with these nodes, you can access data in databases, usually via JDBC connections. You can read Excel files, you can read CSV files, you can connect to the Twitter API, you can connect to big data technologies like Hive or Impala or Spark. You can crawl the web, you can access RESTful web services, and so on. So you can access a huge variety of data sources and load data into KNIME, perform transformation or data prep tasks. You can do partitioning, filtering, binning, handling missing values, and so on and so on. Once you have prepared your data set and cleaned your data set, you can then hand this over to the next category of nodes, the analytical nodes. These nodes give you the possibility to build predictive models, for example, to do clustering, frequent item set mining, and all sorts of these advanced analytics methods, basically. There's also a lot of visualization functionality available in KNIME. We have a huge variety of nodes that are based on JavaScript. With that, you can build, or you can easily build nice views, and these views are then rendered in your web browser, all based on JavaScript. We also have other integrations, but these are the nicest ones. And then in the end, there's also the deployment section. Here you can write back your data to a database, to data files. You can save your predictive model that you just have trained somewhere, and so on. So this is mostly for table-based data consisting of rows and columns, but you can also process different types of data. For example, textual unstructured data. We have a text processing extension. If you have network-based data, there is a network analytics extension. You can do image mining, for example, if you have images. You can even do even process chemical compounds or genetic sequences or things like this. So there's different types of data can all be processed in KNIME here. And I already mentioned it, there is also an R and a Python integration. So for those of you who like the visual analytics platform, but sometimes also like to code, or for those of you who have very specific libraries and want to integrate them in KNIME, this is also possible. You can run your own Python code in KNIME, you can run your own R code in KNIME and integrate those packages and libraries. And I already said it, KNIME is based on Java and it's open source. This means you can also implement your own set of nodes, and you will then not really show how you did this, but you will show a couple of nodes that have been implemented, custom nodes. So you can extend KNIME and create your own extensions if you think that these are needed and you don't find the right functionality. So all of this is open source. This is part of the analytics platform. This is just to give you an idea where KNIME is used. We started in pharma and healthcare, basically, but then KNIME was also used in other industries or application areas. We have users and customers in the finance section, in retail, customer intelligence, and also manufacturing. Then there are a couple of analysts ratings. One of them is the Rexa Analytics survey that rates KNIME very well in terms of user satisfaction, and I'm pretty sure you know the Gartner Magic Quadrant. KNIME is ranked there very well, and there is also the first predictive analytics wave, and yeah, so there are a couple of analysts. Some rate or rank KNIME better, some rank KNIME worse. Yeah. As I said, this is the KNIME Analytics Platform. It's all free and open source. You can start using it, simply download it. All the extensions that are available there are free and open source. All the extensions that are coming from KNIME, There might be extensions out there from our partners which are commercial extensions, but the KNIME extensions, they're all free. So you can also use the text mining or the big data extensions. Yes. Yes, so I can distribute the slides. We also have a commercial product. This is where we generate our revenue from. This is the KNIME server. And usually if you're working in a team or working for a company or enterprise, then the KNIME server might be interesting for you, but I'm not going into detail about the KNIME server. I just want to mention that we have that kind of product as well. Good. Okay, so this brings me to the demo. To the demo part. Before I start the demo, the inventory optimization demo, I start with that one. I'll give you a little bit of background, what I'll show you in that demo. And so the first one, the inventory optimization use case here. The business case is basically to predict the consumption of historical data based on historical data, and based on this predicted consumption of this future consumption, we want to calculate a safety stock, basically the optimal inventory level that we need for our items. So if you think of a company that has specific items and that has a warehouse, these items sitting on the shelves, then you definitely want to avoid understock. If there is demand for those items, you want to be able to sell those items. So you want to avoid understock, but you also want to avoid excess stock, because if you have too many items sitting on the shelves, this is basically capital, or this is money that you cannot use, and also the warehouse costs are higher than they should be. So there are basically two steps: the consumption forecast, and based on the forecast consumption, there is a formula to compute or to calculate the safety stock. We have a couple of variables for this. First of all, the business analyst, of course, they need to define for which items they want to analyze the inventory level, the ideal inventory level. Then there is the forecast consumption, and we applied this function here, or this mathematical formula. It's a standard formula, it's not something special, and there is a variable alpha, which is the safety level. This basically gives the business analyst the chance to be very safe or a bit risky with the safety stock. It's a variable between 0 and 1, and this can be defined by the business analyst. And we put all of this together, the forecast consumption, the safety level, the items that we want to use for the optimization, and then create a number of the ideal safety stock. So the usual way, if you want to think of, for example, a Python script, if you code this in Python or R, or also if you're using the KNIME Analytics Platform and you build a workflow, would be like this, that you have these two parties. You have the data scientist and, for example, a supply chain analyst. This is our business user here, and this is our data expert on that side. And the data expert would take, for example, KNIME or Python or any other solution and build a solution and come up with a model to compute, or a number in this case, to compute the optimal safety stock for an item A. And then hands it over to the supply chain analyst, but maybe the supply chain analyst in this case wants to have that number for a different item B. So this goes back to the data analyst, the parameters are changed, and then it goes back to the supply chain analyst, and so on. So this goes back and forth a little bit. In the end, the supply chain analyst might need the number for a totally different set of items, and also want the safety level to be changed, and then this goes back to the data scientist, and so on. So what I'm going to show you here is a demo that was built, a solution that was built by the data scientists, the experts, but was made available on the KNIME web portal for the business analysts by a very easy to use web interface. So under the hood, there is basically all the work running that the data scientists did, the workflow, the complex KNIME workflow, but the front end is a very easy to use front end for the business people. And this is the first use case. So first of all, I'm going to show the workflow. That's the KNIME Analytics Platform, and this is how the solution would look like for the data expert, for the data scientist. So these are specific nodes. These are rep meta nodes. I'll quickly show you what's inside these meta nodes. These are encapsulated packages if you want, and inside these packages there is a lot of stuff going on. For example, here a clustering is performed and so on. I'm going to show you how this looks like for the business analyst in a second. But this is the view for the data scientist. The data scientist can use the tool, can use those nodes, and can perform these operations on the data. And once this solution is ready, it can be deployed on the KNIME server and made be available in an easy-to-use way for the business analyst. I'm now switching to the browser. This is a KNIME server running on my local host here. So this is just a demo server. I'm logging into that server, and this is now how the business analyst or the business user would see the solution. We see a couple of workflows that are available. I'm going to the inventory optimization use case, and I'm starting that application. And in a first step, this is basically just something like a welcome page. It simply explains the application that I'm using now. It's about the inventory optimization. Here are a couple of details, and then I can really start it and click next. So first of all, we have to specify a couple of items that we want to use for the inventory optimization. We will then later on go step by step through this application and collect all the variables, all the data that we need to then in the end come up with the optimal safety level. So this is how the business analyst sees that. In the beginning, the business analyst can specify the items. Here we see all the items in our shelf in the scatter plot. This is a JavaScript scatter plot. It's a node in the end. Just to quickly show you how the scatter plot looks like in the KNIME workflow. It's basically this view here. So this view is created by the usage of that node. It's a node that creates a view. Every node performs a specific operation. This operation in this case is to create a view, and this view is exposed in the web portal. So this view gives the business analyst now the possibility to select a couple of items. I'm selecting those 2 items here. On the y-axis we have the inventory value. On the x-axis we have the number of items in the inventory. So we see that these 2 items are the items with the highest inventory value. So what happens? Can we avoid this from going to standby? Okay. Which button do I have to press for the next time? Just any button or any button? Okay. Yeah, so in this case, I'm going to select the blue items because they have the highest value. So hopefully we can save the most money basically by optimizing the inventory value for those 2 items. We can also scroll down. Here we have a detailed view of the, in this case now, selected items. We see that these items have specific features. They have a part ID, they have a lead time or a mean lead time. They have, for example, an overall consumption. They have a number of how many items are currently in the inventory. They have the average days to sell and so on. So all these numbers, they come from our database, for example, or from our item database. So this would be the first step. And under the hood, there is still this workflow running. So currently we are at this step here. and we can dive into that rep meta node to see what's going on. So we see the table view, we see the scatter plot and the decision tree view, and we can do some selections, and then we move on to the next step, which is this one. It's the third page, the inventory review. And I'll do that by clicking next. Exactly. This will remember the choice. I can go back and forth. So here's the back button, and back would mean then now we are here and we could go back there. So on this page, we see a couple of KPIs for the selected items. We see the overall inventory value, we see the average days to sell, and so on, and we see also an excess stock value. If you remember one of the first slides, we saw that we want to avoid excess stock because it's basically unused money sitting on our shelves, and we have quite some excess stock money here that we can reduce, or we should reduce. What you can see here is there is also a consumption prediction and supply and inventory level plot. So this is in this application, this is the present day, and everything here on the left-hand side of this red line is the past, and everything on the right-hand side of this red line is the future. So here is our prediction basically, and on the left-hand side is our historical data. We have a supply that we can see here, the orange bars. This increases our inventory, and we have a consumption. These are the blue bars here. This decreases our inventory value, and the green bars here indicate our overall total inventory. We see here if we have consumption without any supply, the inventory will go down, and here we can see the consumption. This consumption is forecast. This is based on an ARIMA model, which was produced before or trained before. So I can also show you that. This was in another workflow, in the data preparation workflow. There we did a bit of data prep and cleaning, and we also trained this ARIMA model. It takes a bit to load. So this was also created by a data scientist, by a data expert user. Let me quickly check. Here it is. So we have a load node for that. This is the ARIMA learner and the ARIMA predictor. If you're dealing with time series data and you want to do time series forecast, then these nodes are very useful. So these predictions, they already have been made. And as the business user, I now can for example, check the accuracy to get more confident in the model or not. And based on my personal feeling and the confidence, then I can decide the safety level that I want to apply in the next step. So here we have a switch, so I can now change between two paths. First of all, I'm checking the forecast accuracy. This will take a bit. And here we basically see how our model performs. Again, this is the present day. On the left-hand side is the historical data. We have the real consumption, which is the blue line, and we have the forecast consumption based on our ARIMA model, which are the orange bars. We can see that we're missing some peaks here, but overall we're doing not too bad. So we have a balanced error of 0.13. This means roughly an accuracy of 87%. And now, as for example, here as the business user, I can decide if I want to trust that model or not, if this is good enough for my purpose or not. So I can go back and to then apply that model on my selected items. First of all, I need to specify the safety level. Here, with that slider, I can specify the safety level between 0 and 1, or 0 and 100, basically. And the higher the safety level, the more the higher the safety stock, or the higher the number of the safety stock, and the more items I will have ending up in my inventory. Okay, so if I want to be very sure to fulfill all the demand, then I can turn this up to almost 100, 99 in this case. If I trust the model and some items are not super important to be on the stock, I can turn this down and save money basically in the warehouse. So what I'm doing now, I'm first putting this to 90 and then executing this, and I can go back and change the number, and then you can see the difference, what's basically happening. So now we have all variables together. We have the safety value, we have the items, and we have the model. And this combined then in the end will, or with that combined, we're able now to compute the safety stock here. And we see that we have a huge excess stock, so we don't have to order these two items for a long time. In this case, we don't have to order until July 1st. If I'm now going back and change the safety level to, for example, here 99, you will see that also the safety stock will increase, and we will need to start ordering these items before. So here now our safety stock is about 1,000. This means we don't have to order for a couple of months, but then let's quickly sort this. Then starting with here May 2017, we need to order, and this is the forecast supply combined with the safety level. So this is the stock basically of, or the supply of items that we should order based on the algorithm. All of that is a KNIME workflow. Here, for example, we have the switch, so we could see the forecast accuracy here. Then we have this other page here to specify the safety level, and in all those pages you can see they're basically created out of KNIME nodes. So in the end, it's a KNIME user or a data scientist who created those workflows and then deployed them, in this case on the KNIME server, to make them available for the business users. Yes. Exactly. Yeah, exactly. Yes, so every box is one page, and what will be shown in the page can be defined by you or by the KNIME user, basically. So whatever nodes you put here in this page will then be shown in the end in the web portal. So all the JavaScript used, they will be exposed in the web portal. All the we call that quick form nodes, they allow the user to specify some parameters. They will be exposed in the web portal, and these parameters will be then fed back to the workflow, and then the workflow can perform the operations according to these parameters. For example, if you think of a k-means and you want the user to specify the number of k, then this would be a parameter, could be specified here. It would be fed back to the workflow, and then the node would take that parameter and use it on the algorithm. So this is the whole idea about it. Yes. Yes. Exactly. Yep. That's the point. So sure. So you can create your own models, your own predictive models, and you can save them and reuse them later on. So this is basically what happened here. In the first step, the data was cleaned and prepared, the original data set, and also as part of that cleaning, a forecast prediction model or a time series model basically was built using the ARIMA nodes here. And this model is available here at this model port, and this model was saved so that the other workflow then can reuse it. So you can you would need to retrain it again. So if you want to change the parameters, you always need to retrain the model again. For example, let's see, I can't open that one because those nodes are not executed. But if you want to apply different parameters, you need to rerun the node again. So you cannot do that on the fly, basically. But you could do that by creating another web portal application, exposing all of those parameters for this particular algorithm as quick form nodes, and then allowing the user to change those, and then the user could go back and forth, change the parameters, and retrain the model and run, for example, again this inventory use case. Yes. Okay. It's like pick one. So you can save those results in different files or databases, if this is what you mean. You can also create a report, for example. You can create a PDF report. So you can create a visualization, a pie chart or some other chart, and then export this into PDF, and then share this PDF report. So this would be also possible. If this is what you mean, or do you mean something different? Okay. You can do this, but not with the web portal. With the web portal, you need to start at some point, click next, 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 and then end up at some steps, basically, at some stages. But what you can do is the KNIME server has also a REST API. And with that REST API, you can take every workflow that you have, that you build, and you can put this on the KNIME server, and then this workflow is exposed as a RESTful service on this on the server. And basically you can implement your own UI, for example, a JavaScript-based UI on top of that REST service. This means you can have your own application, for example, a JavaScript application that communicates with the KNIME server via REST and triggers complex operations or workflows or something like this. And data can also be sent. So you can send data to the server, to this REST service, and get data back. Yes, so with that, it would be possible. Okay. So these nodes, they cannot be changed. This is basically these nodes, they're open source, so you can go to GitHub, check the source. You could copy the source and create your own node and change it a little bit. This is possible, but you cannot do this during runtime. So you would need to take a copy of that node and then exactly, yeah. Yes, but if you're a Java programmer and if you're comfortable with Eclipse, then this is not too complicated. So it's basically just a couple of interfaces that you need to implement, and you can take the code, it's open source and available on Git, simply copy it, do a couple of changes, and then you have your own node. Okay, any other questions before I? Yes. the report, for the reporting, we use the BIRD. It's called the Business Intelligence Reporting Toolkit. It's also open source, and it's part of Eclipse, or it is an Eclipse plugin. So it goes very well together with KNIME, because basically KNIME is also technically an Eclipse plugin, so it's based on Eclipse. And you can prepare a data set and also views, images in KNIME, and you can pass them to BIRD, and in BIRD you can create your report. You can take the images from KNIME and the data from KNIME, and then do whatever BIRD allows you to do. So there is a lot of functionality that you can use that is provided by BIRD, and BIRD also provides to create, or the functionality to create reports as PDF, but also as, I think, Microsoft PowerPoint, or as Word documents, or other documents like that. And if you want to simply create an Excel file to get your data out of KNIME, this is possible with the Excel writer. So there is a simple node for that, and you can take any data table basically that you created in KNIME and then write it out as an Excel file. This is also possible. Okay, any other questions? Then I will move quickly on to the next demo, and I will not go too much into detail with the next demo, but yeah, just show you what this demo is about. I think I have one slide. This demo is more about visual analytics. It's kind of a demo to show the drill down abilities. It's based on customer data, so we have a customer data set. We want to review that data set, and we want to able to do a little bit of slicing and dicing of the data set, and then to drill down into a specific customer segment, and maybe take a one specific customer and compare it to similar customers. And in the end, we also have a churn analysis that we use not only for predictive modeling, but also to kind of explain why churn is happening, or what features are relevant for customers to churn. So I quickly stop that one. That's another workflow. I need to load it. This takes a little bit. The data set it's not really a large data set, but it's kind of a medium-sized data set, and this is all running on this laptop here. While this is loading, I can show you the workflow. This is how the workflow looks like for the data scientists, for the KNIME users. Here there's some data is imported. This is all provided with a CSV file. Some KPIs are calculated. This is just a bit of grouping, basically, that is done. Some group by operations. We have an intro page here, simply explaining the application, and then here we can step by step dive more into specific customer segments. The data cleaning, depending on the data. So I mean, KNIME provides a lot of functionalities, for example, to handle missing values, to do filtering, to do pivoting and grouping and joining, and so whatever the data basically needs, but all the functionality is there in the form of different nodes. We can have a quick look here in this KPI calculation meta node. There is some missing value handling taking place, some column renaming, some conversions from string to dates. With the date representation, we can perform specific operations, for example, like the time difference and the date difference. And then there is some grouping done. So it's, I would say, standard data prep that is happening here. Okay, in the meantime, the first page loaded. So this customer data here is about B2B customer data. there are a couple of KPIs. For example, we have this is the mean external price of our products. Here, the number of invoices that this company sent, the total external margin, and so on. We also see here a distribution of the revenue of this customer data set, and we see that most of the revenue is somehow produced here in the western part of Germany. This is just a first rough aggregation of all the customer data here, and I'll do the next step, and in the next step we see more details. We see again a scatter plot that plots our high-dimensional customer data. Let's select a couple of customers here. On the x-axis we have the aggregated revenue. On the y-axis we have the external margin in US dollars. We can change those axes, so if we want, for example, here we have the aggregated revenue, or if we have we have different features here that we can all inspect, so we can do a bit of slicing and dicing and change the representation accordingly. Here we can see the details of the customers or of the specific data records. We can see the details of all the records, or we can see the details of only the selected records, so the selection has to be here. And this goes vice versa. So if we unselect, for example, the blue one here and the green one, then they will also be unselected in this view. So these views are communicating with each other. We see the details here of these customers. There are also companies. It's a B2B business case, and in this case, we see that most of the revenue is generated in the manufacturing application area or manufacturing industry. Most of the revenue, but also most of the margin. So we could then be interested in this manufacturing sector. Here now we can specify one sector. In this case I will specify manufacturing, and then click next, and then deep dive into the manufacturing subset of this customer and get more information about this as well. What we see here is also a date picker, and this in the end helps us to define churned customers. Here we can specify a specific date, and if after that date no invoice was sent to a customer, this customer is then be considered as churned, and this will help us to label the data, and in the end we build a predictive model on these labels, and we try to figure out which features have the most impact on churn on the target variable, if you want. So I'll click next to drill down into the manufacturing section. Again, we have a scatter plot here to see details about customers in the manufacturing section. We see details here, and we could now then, for example, pick one of those and compare one specific customer to the closest neighbors, or to the nearest neighbors, and see how this performs, how this customer performs. I do this as well. I think here we have specified 7 or 10 nearest neighbors according to specific features that we could that we have specified in the workflow, and we see that this is the selected one is doing a little bit worse than the similar one in terms of revenue, but when we look at the margin, it's a little bit performs a little bit better. So this is just to give you an idea about the drill down operations that you can perform. You can select subsets and so on, and create visualizations of those. And the next page, or the last page also that I want to show, is the churn application. we have specified this particular date at the beginning, and if after this the specified date no invoice was sent, a customer is considered as churn. So we have a yes/no label, 0 and 1. 0 means churned, 1 means churned, and 0 means not churned. And here we build two predictive models, a logistic regression and a decision tree. These models have been built not to kind of perform the best accuracy, but to get some insights of what features are related to that specific, to our specific target variable. For the logistic regression, we can sort by the set score. Here, the most negative set score is mostly related to the churn, to churn yes. And what we can see is, for example, here that customers from Spain or from Germany or from France, they're likely to churn. If we sort this the other way around, for example, here customers from Turkey, they're not so likely to churn. There is also another visualization of this. This is the sunburst chart. Here we have the churned ones. You can see here the label. These are the churned and these are the active customers. And here we can now see the subsets. For example, these are churned customers. A big fraction of those churned customers come from France, Germany, Italy, and so on. And then you could even drill down more into the application area, from which application areas those customers churned. Okay, I think I'm already over time. Are there any questions so far? No. Okay, then I'll stop here. Yes. Yes, so first of all, the data scientists, they can upload their work to the KNIME server and they can share their work and others can download. If you have a group of data scientists, they can upload the workflows, download them. And it's also, there is also kind of a forum that is brought or shipped with the KNIME server, and it's called the Workflow Hub. And on this hub, all the workflows are available and you can comment them. You can also rate them. So you can say, oh, this is a very good workflow, but please change this and that, and then it would be even better. Or so you can have discussions about every workflow, and then it's up to the data scientists to implement those feature requests in the end. But there is kind of a platform for those social activities shipped with the server. Yeah. Okay, then yeah, I will be here anyway for the whole evening, so if there are any questions, any other questions, then feel free to approach me. Thank you.
Okay, thank you very much, Kilian. Can take. So thank you, Kilian. I think it was very interesting explaining the functionality of REST APIs. Actually, we are building a system now for a client, a fraud detection system. And the next step with this system is that we're going to integrate it with some other system. So from that other system, you can, with the REST API, call for a certain organization number. And you can, in KNIME, calculate the probability that this organization is a fraudster or not, and you can return an answer. So this is a great way of integrating the systems, I think. And if now we're going to move on to something completely different. So now we're going to talk about something completely different. We're going to talk about data anonymization, because this is getting increasingly more important. Because some people might think that, okay, we have a personal number, we have a name, so let's remove that and we are done. But it's not that easy, because you can still identify persons in that data set. And you can just go on and on and on and on for each attribute. So if you are just removing all the columns, yes, then it's getting safe. So we're thinking that the data should be as open as possible, as closed as necessary. And this is not a job for a person to work with. You need machines to make sure it's safe, to identify the risks, to have the strategies for treating that data, to make it completely safe. And in the long run, you're able to make some data that you can, open data that you can share to anyone, and still it's useful. That's the point. Okay, Artem, please go ahead.
Thank you everyone for coming tonight, and I'm glad that there are so many people interested in data anonymization. Okay, let's start. So the presentation will go as follows. So first of all, I will introduce the problem of data anonymization. I think so. Now it's better? No? Okay, better. Okay. Then we will discuss some basic anonymization techniques with some examples. Then I will introduce the most well-known and straightforward anonymization strategy that's called k-anonymity. And then we will have two examples with KNIME. So first we will synthesize the data set, and then we will anonymize it, and then we will have some conclusion remarks and maybe questions. Okay, let's start. Nowadays, processing of big data is already become a routine, but of course there could be some restrictions tied to data security and data anonymization. For example, in some organizations, for example in government organizations, you might have different access levels depending on what kind of data can be open to some specific users. For example, doctors may have access to some sensitive data like medical diagnosis, or some security data security specialists might get some access to identification data. The second use case is electronic commerce. It's obviously very urgent problem to keep data of your customers safe, because such that data as credit card numbers and address and maybe information about the purchases might be sensitive and identifying. One more use case. According to PSI, it stands for Public Sector Information, government facilities in European Union must give away some open data, but at the same time it's also so these people who are responsible for preparing open data, they have to follow some basic rules. So none of sensitive data or identifying data should be given away. And now in European Union, GDPR is taking place, and it regulates how this data can be treated, because all this data that can be transferred, stored or processed, it should follow GDPR requirements. And there are two cases, there are two possible solutions that can be applied for this problem. So the first of all, it's obviously data anonymization, and the second solution can be using synthetic data. So synthetic data is data that looks like or almost the same data that is you have, but it doesn't lead to any de-anonymization of some if you have some personal information. Okay, and before going into the anonymization techniques, let's discuss what kind of data attributes we might deal with. So the first attribute is identifying data. So it's pretty simple. So it can be name, address, personal number, credit card number. So every information that can directly lead to person identification refers to identifying attribute. Then goes quasi-identifying attributes. So these data cannot directly lead to identification, but in case some adversary or malicious person gathers a lot of this information and has the knowledge that and the data set where some specific person, his target is stored in this data set, he might use these quasi-identifying attributes to identify the target person. So basic examples of quasi-identifying attributes is gender, date of birth or age, maybe zip code. Next attribute is sensitive attribute. So this kind of data is not processed at all, so it cannot be anonymized because it's important. At the same time, this kind of data should not be matched to some specific person. So the most typical examples of sensitive attributes is obviously medical diagnosis or income. So nobody wants to be matched to some disease. And the last type of attributes, it's like the rest kind of data. So these data cannot help anyone to identify the person, and it's not sensitive. So this kind of data could be anything. So for example, some internet shops may gather information about their users' operation system, web browser, the number of clicks, clicks on advertisements, and so on. So this is all about the attributes. Okay, let's start with basic anonymization techniques. So here we have the lists of 8 points, and as you can see, the last point is synthetic data. So actually we have two problems: generation of synthetic data and anonymization problems. And here generation of synthetic data can be a solution for data anonymization in some cases. Okay, let's start. So attribute suppression, it literally means removing some identifying data, like as we have an example, the name and surname is deleted from initial list, and in the results table we don't have these attributes. So it's pretty straightforward. Everything that can directly lead to person identification must be removed from your data set. Next technique, character masking. So quasi-identifying attributes, or in some cases identifying attributes, can be partially masked. In some cases it might be useful because for example, we have an email with a message like, please confirm that this is your credit card number or this is your telephone number. But in this case, instead of revealing the whole information, we are just given the part of it. So in this case, we have the last 4 digits of the phone number. Yeah. Well, actually, it's up to you. For example, you may have a database that's encrypted and has very restricted access that contains the whole data. But if you're going to somehow process with this data or give the access to someone, you may restrict the access. You may apply these techniques. And also you have to, follow GDPR in case you are working with data of European Union citizens. And you told that you have 2 questions, no? Okay. Okay, let's go next. Pseudonymization. Pseudonymization can be done in 2 different ways, with encryption and tokenization. So let's discuss the first. Encryption. It basically means that you have some algorithm that somehow encrypts the data. It can be reversible, as for example, as you mentioned. Yeah, so you probably in some cases need to get back to the initial data, and irreversible. So in this simple example, so I just used SHA hash function to and applied it to person number. And yes, it's still unique because it will be unique for every unique string, but at the same time it gives away no useful information at all. And the second option for pseudonymization is to use tokens. So in this case, you will also need the intermediate table that will contain information about keys as tokens and real values. So one more advantage of using tokens is also that token allows you to keep the structure of the data. So in this case, we have the tokens containing 10 digits divided by minus sign, the same as for real person number. Next technique is generalization. So this technique is pretty flexible. Instead of giving some accurate and precise values, you can actually control how you will lower the accuracy of the values. So instead of giving away the real date of birth or real age, you can have age groups. At the same time, you can even create the hierarchies for generalization. So imagine that at the first level of this hierarchy, you have the age groups with the step of 5 years, like 20 to 25 years, 25 to 30 years, and so on. On the second level of anonymization, you have age groups with step of 10 years, 20 to 30, 30 to 40, and so on. And obviously, it can be applied to any other attributes. For example, you may have the intervals of zip area because, for example, we know that the first digit stands for län, or the province here in Sweden. So 1 stands for Stockholm and Stockholm province, and you can set up the interval just for Stockholm province and so on. Next technique, data perturbation. So this is actually means that you may quite distort your data, and obviously you or add some noise to your data, and you can also control it. For example, so here I use just the most simple technique. I just rounded up the values for the weights and heights. In some more sophisticated cases, you might use, for example, Gauss distribution. So you can calculate the mean value for the whole column and use this mean value and standard deviation to generate the values for this column. This is also an option. Next technique is data swapping. So data swapping literally means that you just shuffle the values inside your table. So the main advantage is that the whole data is actually still stored in your table. However, the values doesn't correspond to to the original data set. So this technique can be applied if you don't want to lose the information at all, but still there is a restriction. And restriction is that you don't, so the relationship between the attribute values inside one record should not be significant, because probably if you are trying to get some distribution of or try to find some correlation between the age and the city, so this information obviously will be lost. And next technique, data aggregation. So it actually means that we do not provide initial data at all. All the data that we can give away is the summarized values aggregated by some other attributes. So in this case, so it's very simple. We have four people in our data set, and here we have just 3 tables about information of average income generated by gender, occupation, and zip area. You can even can save, so you don't have to reveal the size of initial data set. So this data aggregation technique can be very useful if you're going to make some open data from your data set. And the last technique is generating synthetic data. So here in the marked blue, we have some synthetic data that actually looks like original data. So it's very advisable for if you're going to use synthetic data to make some preliminary analysis of the initial data set you have. So probably it can be very important to define the ratio or the distribution of gender, age groups, and some other parameters in your data set. So also you probably can define some outliers, and once you did this preliminary analysis, the synthetic data can be extremely accurate, and probably it can be used in machine learning. Okay, this is all about basic anonymization techniques, and now we are going to... Yes? Well, probably if you have trained some machine learning models on your... Yeah, probably if you have some lack of data, you can expand it. Well, actually, probably you don't have the opportunity to assess it, but preliminary analysis is actually made for this purpose. So you will try to find some relations in your data. This way you can try to prepare this synthetic data set as much accurate as possible. Yes? Yeah. Yeah. So you mean that you're going to use join between different tables, or? Well, but it also actually depends on what kind of data you have. So probably each case can be unique. So you have to put a lot of efforts for data synthesis. Okay, K-anonymity. So K-anonymity is one of the most well-known and old and straightforward anonymization strategies. So the main requirement of k-anonymity is that once you apply anonymization techniques to your data set, so the quasi-identifier attributes must have values for at least k or more records in your data set, so they cannot be distinguished. And these groups that cannot be distinguished by the values of quasi-identifier attributes are called equivalence classes. So I will have some examples. So if somebody is confused, probably you will get it pretty fast. But this is just a formal description of k-anonymity model. Okay, so now I will show you some KNIME workflow that we are going to work with. So this is just a brief description of what kind of data we are going to synthesize. So we have a list with Swedish female and male names, list of surnames. We have a data set with real Swedish zip codes tied to cities and provinces. Then we have some excerpt for occupations, and it was taken from ESCO database. It's European skills, competencies, and occupation database. It's open data; everyone can use it. Then we have some distribution for income, age distribution, and family status distribution that depends on age distribution. Okay, here is the probably I can I have to. Okay. Yeah. So Kilian already explains how it's working in KNIME. So you have these nodes, and just each node is the purpose of each node is somehow to process the data. And here we have several meta nodes that's contained inside of each. So there we have some workflows inside of each meta node. So we have some gender distribution, as I mentioned. Then we go to creating names of the person that will be stored in this list. So we have names. We split it by gender. Then we have a list of surnames. We have random matching between names and surnames. Then we so there are some other join nodes in KNIME where you can set up like a foreign key and primary key, but here it will be completely random. So this is synthetic data. We are just creating some data set for what. Then we have a function for age distribution. Probably I will not I will not describe it in details. So if somebody will have the questions, we can discuss it after the presentation. But okay, let's show what we have here. So here we have a data set. Oh, probably I have gone a little bit forward. Yeah, here. So here we have a data set with 5,000 records with information about some personal data about people. We have gender, name, surname, age, data about their occupation. So code stands for codes of occupation in ESCO database. Then address, so it's zip code and city. Family status, income, and this is just auxiliary column that will be used for creating the hash function. So after that, we encrypt with hash function name and surname. So this is kind of the first step of anonymization. So we get rid of names and surnames in dataset, and then we are going to apply further techniques. So we are going to apply that K-anonymity model. Just a couple of words about this. So we have been working with KNIME, and also we were looking for some powerful anonymization tool, because actually every technique that I described before can be applied in KNIME, but you cannot assess how well your data is anonymized. And for example, you cannot apply this K-anonymity model in KNIME. For this reason, we created some special node that uses ARCS library. So ARCS is a very, very powerful library, and they also have the application with GUI, which is also can be used by data scientists. So you can define the strategy how you are going to anonymize your data, but this application cannot be used if you want to make a workflow or a pipeline. For this purpose, we created our own custom node. Here it is, and this is kind of a a beta version. So we just have K anonymity with K equal 5. Okay, let's reset it and start again. So it actually takes not that much time. So this data set now will be anonymized. So I will have some brief description of these arcs. So now we can see how this data is anonymized, and it also satisfies the K anonymity model where K is equal to 5. So as you can see, so this algorithm didn't change any information about gender and family status, but here instead of real age we have age groups. Probably they are too wide, from 0 to 40, from 40 to 80. Then we have the same income groups. Occupation codes are partially masked, and postal codes are also partially masked. And let's have a glance on these ARCS tool. So this is the GUI application that can help you to define the anonymization strategy. So here on the left we have our initial data set, and on the right hand side we have anonymized data set. So as you can see, we have groups of records emphasized by white and gray. It actually stands for K anonymity. So in this case, K is equal to 10. So it means that in each group we have the values of quasi-identifiers, and all of them, they have the same value. So none of these persons can be re-identified. For example, we can imagine the situation when this anonymized data set is somehow stolen by a malicious person, and he tries to identify some person inside of it, and this person might know some background knowledge. For example, the age, maybe income, the profession, the occupation. But even in this case, this malicious person cannot identify any person here. Well, at least he can identify the groups, and the probability of identifying some person is equal to 1 divided by K. So you can increase this parameter, you can decrease this parameter, is up to you. Yes. Yes. Yeah, it completely matches. So, for example, okay, let's 200, record number 200. It's uh, uh, well, yeah. So actually, once you defines the strategies, the models, the parameters of how you want to identify your data, because obviously you might have some other columns, other data, maybe you have some sensitive attributes. You can do everything here. You can save some parameters. Here in ARCS, it's called anonymization hierarchies. Then you put these hierarchies to the KNIME workflow. You set up the same parameters that you used in application, and you can include this into workflow. So these can be done automatically. You don't have to do this anonymization process every time. So for example, you might have different so you have a database, and there are several users that use this database, and each user might have the access to some specific information. You can even set up the anonymization strategy for each group of users. So some of them might know more, some of them might know less, some of them cannot get anything. And yes, so actually this node was created for automatization. Yes?
I think I can answer on that. So it's depending on the size of the data set. You create this strategy, you have the hierarchies, and depending on the size of the data set, the algorithms will pick that level of anonymization in that hierarchy. So it's dynamic.
It's a little bit more complicated, actually. Not only the key parameter is very significant. There are some other parameters. For example, before applying some anonymization techniques, you may choose the weights for each quasi-identifying attributes. And it works this way. So you can change the value from 0 to 1, and the biggest value means that this attribute is important and it should be anonymized as less as possible. And the less weight means that this attribute is not that important, and it can be will be the first candidate for anonymization. Yeah. So also the developers, they yeah, this is also can be useful. For example, there is analysis of each attribute of that we have in table. So it actually says the separation. So here we have in our data set almost equal number of men and women, and it actually shows how much each attributes influence for anonymization process. And here, after the applying anonymization strategy, you will see the same. Okay, and just a moment. Yeah, I'm looking for it. Yeah. Okay. So here is like before and after. Here is the risk of identification of person. Obviously, it's 100% in the initial data set. It's not anonymized. And after applying anonymization techniques, we have reduced the anonymization probability to 10%. So, and in this case, it depends on this K parameter. So it's up to you to decide how much your data should be anonymized. Yes. Okay. Well, actually, KNIME provides different nodes that allow you to work with database. So you can extract some data from your database into KNIME. Yeah, it will be like a workflow. And after that, you can put this data that you are going to anonymize. You can. Well, maybe in this case you can concatenate it into.
I'm thinking you're thinking about some kind of database, some transaction, some system, but the system will not allow you to have age groups and etc. So I think this is more for the consumption of data when you're doing analysis, data scientists, business analysts. Yeah. Yeah, consumers. Because anonymizing in a database, it will not allow you to apply all those techniques. And you will not share a complete database to someone that you don't trust. Right. So it's more reading from that database that you can apply these techniques. Are we running out of time, I think? Should we?
Well, actually, yes.
Have a few
I think I
last words?
Yes.
So, but I think it's really powerful. If you add to this REST APIs, you can actually run that workflow, use this new ARCS node, and you can get the data in real time, actually. So depending on what size of data the analyst request, it will be anonymized accordingly. So I think this can be very, very powerful. Okay, thank you, Artem. Thank you very much. So we are done with the last speech. So I hope you enjoyed this evening and that you gained some insights and that you are feeling inspired to start using KNIME if you don't do already. So thank you very much, and please stay for a while, have some more drinks, and we can talk more about your projects, and yeah, and don't hesitate to talk with me or Kilian or Artem with your projects. Okay, thank you very much.